Hello, can you hear me? Hello.
Yes, I can hear you.
Okay, so good afternoon. Your voice is very low.
Okay.
Hello.
Is it good now?
Yeah, can you hear me?
Yes, I can hear you.
Okay, but your voice is very low and slow. Okay, so we will start our today's class. So basically, you are already completed the 3 days online training program. So basically, rest of 4 days. Means basically, in these 4 days, mainly I will try to discuss about the one day for air quality monitoring classes, and another one day is also try to show you that for the soil moisture data and road monitoring this part, and also other classes. I also try to show you that advanced land use and land cover classification classes. So how you can easily work for the big region and make the land use land cover classification map, and also make the change detection map using the Google Earth Engine platform for using the land use and land cover classification map. Okay, so let's go our today's class. So I simply start the recording. Okay, so now can you see my screen?
Yes, I can see it.
Okay. So basically, when you want to do for the soil moisture, so mainly we are using the dataset soil moisture. It is the globally soil moisture dataset, and this dataset is the availability date is the it's from the 2015 0402 from 2020 220802. Okay, so this dataset you can easily get, and that this dataset provided is that, and basically this dataset is provide the surface and subsurface soil moisture, surface and subsurface soil moisture, and also provide the soil moisture and subsurface soil moisture anomalies. So we can easily get from this dataset, and also you can see the band. So basically you can see soil moisture. This is a surface soil moisture dataset. Its band name is the SSM. Okay, and subsurface soil moisture data, you can see this is the SUSM. Okay, also again soil moisture profile SMF. Okay, so in this time we are want to calculate it. We are want to calculate it the soil moisture dataset. So that's why we need to work with this SSM or surface soil moisture this dataset. Okay, so in this time here you can say I want to work with this dataset. So first of all, I need to open my new code editor, then try to import the dataset and try to make the soil moisture map for any region. So I simply open my code editor.
I'm not getting the idea about the source of this data. Like which satellite is
So
this?
this dataset is that you can see.
No, like previously we have worked with Landsat and Modis
Yeah.
and
So this dataset
Sentinel.
is the NASA GSFC. You can get the all of the information from this dataset provider.
But which satellite and sensors are used?
This is the SMAP. So this satellite is that. So they are using here the satellite drift soil moisture active passive SMAP level 3 soil moisture observed into the modified two layer plumber model using 1D. Okay, so data assembly of the soil moisture and it's computed the alignment with the data interest. Okay,
It's not Landsat, it's not Sentinel,
no, so
it's some
this
other
this is
satellite.
the another satellite. Okay, so this
Okay.
satellite is integrating the soil moisture active and passive level 3 soil moisture observation. Okay, so this satellite is only observed only for the soil moisture. Okay,
Okay.
and this dataset provided is the NASA GSFC, and here you can see all of the information about the soil moisture profile or other things.
But we cannot estimate soil moisture using Sentinel or Landsat.
Yeah, it's possible, but this data set in this time, this SMM or soil moisture, this data set is already created, this satellite. Okay, and so that's why you can see NASA Grodet Flight Center MD. So this is the provider. Okay,
and what is the resolution?
This resolution is that 10,000 meter.
Okay.
We're easily using this for the soil moisture. We can easily using the data set. Okay, so first of all, I simply open my new code editor. So I simply import the data set. I simply copy this snippet ID from here and paste in my code editor. And give a variable name, suppose soil moisture. I can say this name is that, and store this in here. So I simply import. Suppose in this time I want to observe the soil moisture for any region. So I simply import my shapefile. So suppose I simply import the shapefile of I simply import the Bangladesh country boundary shapefile and put this is my RY. So now you can see I simply import my shapefile as well as also my data. And also you can see in this time I want to work with the data I want to work with this band. So I need to select the band for SSM, soil surface soil moisture. So in this time I simply copy this band name from here, and then I simply paste in my code in here. So I simply paste. So I simply just take another variable. Suppose put the variable name is the SSM. Okay. Then I simply call the object or call the variable name, and from this I simply use the select function, and then I simply select my band SSM. Okay. So now it's selected, and then I also need to observation date period. Okay. Basically this data set provide, you can see time period is that year it will be start from 2015 or 2022. Okay. So I simply select my time period. So now I simply take the another variable. Suppose I can simply put the variable name is the filter date. Okay. Then I simply call the SSM, and from this I simply filter my specific time period. Suppose I want to observe the soil moisture data between a specific time period. Suppose year of 2020, 1st January, from year of 2020, December 31. Okay. So I simply select this. And now I want to check how many images is available for this time period. So I simply copy the filter date and paste here and click to the use here the size function, size, and click to the run. So now you can see we can get the total 315 images between this time period for the soil surface soil moisture dataset, and this 315 is the for the global valley. Okay. So first of all we calculated the global soil moisture data, then which area I want to need I can simply click. Okay. So in this time you can see this 315 you want to check the what is the time difference between one image to another image. What is the time difference? I want to check it. So I simply just simply copy this filter date, and now you can see we can get the result. All of the images, what is the specific time? Okay, we can get. So I simply click the feature. So here you can see. Okay, so basically you can see this interval is that 3 days. Okay, so I can get the soil moisture every single image. You can see every 3 days. So first image you can see 2020 3rd January, then 6th January, 9th January, 12th January, 15th January. So every 3 days interval I can get total 315 images for 1 year. 2000 sorry, this is a 2 years from 2020 to 2022. Okay, so we can get this result between this time period 315 images, and each day 3 days interval. So in this time I want to need to reduce this image collection, so I can easily work with the different way for reduce the image collection. If you want, you can use the average pixel value of soil moisture data. If you want, you can also get the median pixel value of the soil moisture data. So in this time I want to take here the average pixel value result. I want to take the average pixel value result, so that's why I simply take the another variable. Suppose I can simply put the variable name is the average SSM. Then I simply call the filter date, and then I simply use at the reduce. I want to use at the EE dot reducer dot in. And then I want to just show the result in my map interactive view, so I simply use at the map.add layer, add layer, and then I simply just call the variable name and paste it and click the run. So now I get the soil moisture data set between this time period for the whole world. What is the condition? In this time you can see this result showing act as a white color because I did not add any visualization. So I simply added the visualization, then check the result, then I can easily understand what is the condition, the soil surface soil moisture. So I can simply go to this information sheet about this data set, and then I simply copy their default color code from here. So I simply copy the visualization color code from here and then simply paste in my code editor. So I simply paste here. Then I simply copy the variable name, just simply copy and paste after the object name and click to the run. In this time you can say I can get the colorful map and I can easily understand about the whole world for the soil moisture. So you can see in this time you can see when I click this part I can get the what is the condition about the soil moisture. We can get the result. Okay, see. Yes, suppose in this time I can get the result for the whole world, but in this time I don't need for the whole world. I need only for the region. Suppose I need the result for the country boundary of Bangladesh. Okay, for this region. So for this I simply take another variable and give the variable name is the study area, and then I simply call this variable name, simply copy and then simply paste here, and then I simply use the clip function. It's just clipping with my shapefile. My shapefile is that RY, and then I simply copy the variable name and paste here and click to the run. So now you can say I can get the result for only for the Bangladesh region for the soil moisture result I can get. Okay, so we can get the soil moisture result, and when I want to check the result, So in this time here you can see when I click on this the coastal area or coastal land area, then I can get the soil moisture. This is the high 25.39. When I click on this place, another place, I can get this like this. You can see this result. So basically the coastal land or coastal area, we can get the soil moisture or soil content capacity is the high. Okay, so but when I want to in here, there you can see we can get the soil moisture like this, and the high is that you can see coastal land area. Okay, so this is our map for the soil moisture map for the Bangladesh. So if you want, you can easily export this map. We are already covered this part, how you can easily export this map and how you can easily import this map in ArcMap software for making the map layout or other things. Okay, in this time this map is showing the result for this year of 2000. Suppose you want to need the result only for the year of 2021, so you can simply change the date 2021, put here the 2021 and also put here the 2021 and then click the run. So now you can see it will be created the map for the year of 2021. Okay, suppose you want to need the map for year of 2020, you can simply put change the date, then you can get the every single year map. Okay, and in this time when you want to create it the time series chart, then you can get the data for every 3 days interval for a 1 year. Suppose you can see this is the one, this is the it will be start from the 2021 1st January. You can get the one data for this date, and another data you can get the 3rd January, then 6th January, then 9th January, then 12th January. So like to up to you can get the whole 2021 or 1 year time series chart every 3 days interval, because when you want to check the image about this data set, we can get the every image their interval is a 3 days. Okay, so now you can see this is the soil moisture data and you can easily export this map. So now if you have any question about this, you can ask me any question.
And do you think it's a good analysis for any agriculture field, like to estimate soil moisture for any agriculture field?
Yeah, you can simply do it in ArcMap software. For you can simply import this map and you can easily calculate the how many. Suppose in this time when you want to calculate it the what is the mean, for this whole area. For the whole area, I want to calculate it the average soil moisture for the whole area. I want to calculate the result. In this time you can see this map is represented the average condition of soil moisture, but I don't know what is the average result of the soil moisture for the Bangladesh. So if you want, you can also calculate this. So for this I also try to show you that. So I simply take a variable. Suppose this variable name is the soil moisture average. Okay, then in this time I simply call this I simply call this average sm, simply copy this variable name and paste here, and then I simply use here a function. It's called the reduce region function. Reduce region. So mainly reduce region is a function when you want to calculate any specific area for anything. Suppose in this time my specific area is Bangladesh. For this Bangladesh region, I want to calculate the average pixel value of soil surface moisture data. I want to calculate this. So I simply use here the reduce region and put all of the argument one by one. So I simply use here the curly bracket start and curly bracket in. Curly bracket in. Then I simply call the reducer. So reducer is a statistical function. In this time I want to calculate the average result. So I simply use here the ee dot reducer dot mean. Okay. So now it calculated the average result. Then geometry. So geometry is my shapefile variable name. It is the AOI. I want to use ROI. So I simply use here the ROI. ROI. Then scale is that 10,000. Then I simply remove all of the things. I can simply use the max pixel because this is a big region and there is a lot of pixel value. I simply put the value 1e 13, 1e 1e 13, and I simply remove it. It's not for this time. In this time, when I want to just print this, print, then I simply copy and then paste here and click to the run. So now it will be showing me what is the average soil moisture data for whole country boundary of Bangladesh. I can get this result in here. You can see 14. Okay, so this is the average condition for the soil moisture in this place.
So,
Yeah.
calculate average of a single month. Like the whole crop season is 5 months, and I want to get average for every single month. Is that possible?
So do you want to need the soil moisture data for every single month? Suppose month of January,
Yeah,
then
like
yeah.
like the crop growth season. I want to cover the whole crop growth season.
Okay.
And it depends whether I take the average of single month or
Okay.
every 10 days.
Okay. So for this, I already create the another code, and in this code, you can get the result for monthly. Suppose monthly, all of the pixel value result you can get for any specific area. So what is the condition for the area? We can easily get. So in this time, I simply discuss this code, then you can easily understand how we can easily do.
Okay.
So this is the, so basically this is our source code. You can see. Okay, so this is our source code. Okay, in this time we are converting the different way for represented our data. Suppose in this time you want to need the data for the monthly or yearly. Okay, then we can easily do for this. So for this we need to know some about the function. It's called the calendar range function, as well as we also know about that another function is that okay, so in this time here you can see, so this is same way. Suppose you can see this is the point. Suppose you can see this is the longitude and latitude for your any specific crop area. Okay, or any crop area. This is your specific coordinate for the crop area. So in this time for this crop area, I want to need the soil moisture data for the for the year of 2006 to 2016, and I want to need from the January to December. So I simply use here the one is January, 12 is December, and this is my start year, and this is my end year. Okay, and then I simply just call my data set. I filter bounds with my area. So in this time I simply use a point. So in area, then I simply use my specific time period, and then I simply set my band name. And in this time you can see I simply use here the month. Okay, so my month is that it will be start from the January to December. So I simply use the January December. I simply put here my start date and end date, start and end date. Okay, so I simply put the in all of the here. So I simply use here the, you can see year sequence. So mainly this is the function. It will be created the sequence. So in this time I want to create the sequence for the year from 2006 to 2016. So I simply use here the start year. You can see I already defined the start year is that, and in year I already defined the in year is a 2016. Okay, then in this time I want to convert the month year. So from this year, okay, so here I can get total 2006 to 2016. All of the year I want to create the monthly data set, or okay, so monthly data set I want to create. So for this I simply take a variable. You can see I simply take the variable by month year, and then I simply call the e feature collection. So mainly this is the feature collection. It's a one kind of function. So this function we are using for the creating the feature or creating the data set, monthly data set, not only monthly but yearly, the same way. Okay, then I simply call the years. You can see years. So in this time I create a function. Okay, so in this time I create a function. This function you can see it will be start from here, this function, and in this function I simply use the function keyword. Then element is the only for the y. So in this time I created the element only for the y, and then I simply use here the curly bracket. In this curly bracket it will be start from the curly bracket in here, and in curly bracket you can see it will be start from in for here. So this is my argument. Okay, so this is my argument, all of the
Where
things.
does y came? Why?
Yeah,
Where does the y came? What is y representing?
y is represented the element name.
Okay.
So when you want
You can
to
give any name, right?
yeah, element, yeah. So y is the element, and in this time I want to use all of the argument using this element. Okay, So all of the things I want to, in this time my target is that my data set is available in this data set. I want to convert in monthly. So that's why I
But
can
you
get,
have not, hold on. You have not defined why before in the code.
no,
Do you need
I
it?
simply, yeah, is
It
in,
is predefined.
no. So this is the element name. It can be anything
Okay.
as a variable.
Okay.
Okay, so I simply, in this time I simply take the function, element name is the y, and then you can say I simply use here, my main target is that I also need to add here the another things. I also need to convert the yearly by month. Okay, suppose year 2006 I need the all of the month. For year of 2007 I need all of the month. For year of 2018 I need all of the month, like this. Okay, so for this you can see I simply take the y is represented for year. Okay, and then this year I want to convert the year, all of the year, for the month. Okay, so that's why I simply return. You can see my argument is start from the curly bracket, so I simply use the returned, then months, and you can see this months and this year I already defined.
Yeah.
Where I define, you can see when I want to take the variable months, it will be start from the January to December, and also I define the years. You can see I make the list from the start year and end year. Okay, so I simply use here the years dot map, then I simply use here the y element name, and same way I want to return all of the month so that it will be showing the monthly year. So I simply call the months because I already defined the months. I add here the map function. I create another function. It inherit the m is represented the month. Okay, so in this time I simply create the another argument. So here you can see it's called the loop function. So I create a one function and including the another function. Okay, on this function. So in this time I simply create the another argument. You can see take a variable w, and I simply use here the data set. Okay, so what is the data set? So data set I already defined. You can see data set. Okay, this data set, my main target is that this data set, when I want to create the data set, it will be showing the 3 days. But in this time I want to need the data set so that it will be showing the result for every month or every single month I want to get the data. Okay, so I simply use here the data set, and this data set I want to filter. How I can filter? I want to filter according to the calendar range. So in this time calendar range, you can see what is the calendar range. I simply copy this function from here, then simply paste in the docs tab so I can get all of the details about the calendar range function. In this time here you can see calendar range function has a 3 argument: start, int, and field. Okay, so start is that start year, int is that end year, and field is that it can be day or it can be month or it can be other things. So in this time you can see, so in this time start year, end year, and field. Okay, so you can see the option field can be year, can be month, can be hour, can be minute, can be day by year. Okay, day by month. So in this time I simply use here the y. So basically this y is represented for the start year, and also for the same y it also represented for the end year, and this is the field for the year. And do for the another way. So in first line, this code is the filter my date, year, filter my year, and the second code I want to filter according to my month. Okay, according to month, and I want to need all of the things as the average result. Okay, I simply use here the average result. Okay, so in this time you can see, in this time this is the w, this variable is stored the average result, but it will be not stored. I want to calculate also. I also need to calculate for all of the result. Okay, in Excel file or CSV file I want to calculate for all of the result. So for this I simply put here the w. Okay, then reduce region, and in this time I want to use here the reduce dot fast. So when you want to use the fast, it will be, if you want you can also use here the mean result, because I want to calculate it the monthly average result. I simply use here the mean. Okay, then geometry is my point, which area I want to need. Okay, then scale, I simply put the scale, and finally you can see in this time it showing, it stored this variable point mean, it stored all of the average soil moisture data for all of the things. So in this time I simply use the return function, so that I simply feature dot null, then set the value, and then point get. You can see this is my band name. So basically this is the another data set for soil moisture. Okay, so this data set you can see. I simply try to show you the data set about the soil moisture. Okay, so in this time they use the dataset global land data assimilation system. This dataset they are using. Okay, so they are using the band is that again the soil moisture 10 centimeter, soil moisture 10 centimeter, soil moisture 10 to 40 centimeters, soil moisture 40 to 100 centimeter. Okay, so in this time they are using the dataset. Okay, so use the band name. So that's why they're simply copy the band name from here and then simply paste. You can see simply paste here 100 to 200 centimeter. Okay, then use here the set by year and as well as set by month. Okay, year, this y is represented year and month is represented the month. So in this time when I want to just you flatten, so this is the another function flatten. So flatten is a function mainly it convert the list into convert the list in flat. Okay, so then I simply print this. Okay, I simply print this. So in this time you can see when I want to show the result and click to here, so here I can get the feature and here I can get all of the things. You can see all of the result I want to get. So I simply click to here, then go to the properties. Here you can see for the month 8 2006 for the month 8 I want to get the value. For the month you can see properties for the month one is the January and 2007, so 2007 January I want to get the value. So all of the things I can get the monthly soil moisture data. You can see monthly soil moisture data I want to get month 5 2006 I want to get the value. So I want to get all of the things. Okay, in here, but it's also better when I want to get the data in Excel file. Okay, so in this time, so that's why I simply export the table as the Excel file. So for this I simply use here the export.table to drive. Okay, then collection, this is by month here, so I simply copy the variable and I can simply put description. So I simply click to the run, our task will be running, you can see. Then I simply just export the run, click to here. So now I want to get all of the data, monthly soil moisture data in Excel file. It not only for the soil moisture data, any data set when you want to need the monthly, then you can apply the same process. Okay, you can need to apply the same process, and this process is very easy. First of all, you need to define your data set. It can be NDVI data, it can be NAWI data, or any data set. Okay, it can be precipitation data, it can be any data set in Google Earth Engine platform. You can simply import the data set. Then you need to create the month sequence. So which month to which month you want to need. Then you also need to select your start year and end year. You need to make the year sequence. Then you can make a function like same function you can use. You can simply copy the function and then you can simply put here the years and also month. Then simply call the data set. Okay, you want to calculate the mean, so you can simply use here the mean. Okay, all of the things will be same. And also you need to add here the band, which band you want to need. So in this time I want to use this band. And then I simply export to table, I get the result. So you can see it will be exporting as a CSV file format. I simply click to here and open in my drive. And from this drive, I can simply download the soil moisture monthly data set. Okay, for this specific point. Okay. And I also send you this practice code, so you can also practice. And not only for this data set, you can also try to practice for another data set. Then the same process, all of the things.
Do you also have code for soil moisture estimation with any other satellites like Landsat 8 or Sentinel-2?
Yeah, all of the code is not available in this time, but if you want, if you have any algorithm or any method, then we can easily try to make the algorithm for this soil moisture using the another data set. No problem.
Okay, you have showed us a paper in the beginner's course about agriculture. I don't remember the exact name, but you have showed us a paper in the slides related to agriculture. Can you tell me what parameters you estimated in that? Or can you share the link of that paper?
Okay, so I also send you all of the slide, then you can easily and also see the share. I also share all of the research paper, then you can easily get. So in this time here you can see, here I can get all of the you can see here, and it represented the month and it represented the value. Okay, here we can get all of the
What is the unit of this value?
yeah.
What is the unit for
So
this
you need
value?
to check the unit from your dataset information. So you can simply go to the dataset information sheet. In this time we are
Because these
using
values are way too high, I think.
yeah. So in
Then
this
the
time we
previous
are
data
using
sets is
the
what
data
is.
set, and I simply go to the band, then we can check the value, what is the unit they are using in here. So just a minute. Okay, so they are using this you can see this data set soil is soil moisture. Okay, they are using this kg per this unit,
Okay.
and this data set they are using the data set unit, you can see. So in this time they are using the dataset millimeter. You can see this dataset unit.
Yeah.
Okay. So in this time we can get the result about the soil moisture data, and using the same process you can easily download any CSV file, monthly CSV file, not only for the soil moisture data, any dataset which you want to need. The same process all time. Okay. So in this time, if you have any question, you can ask me. Any question?
No, I've already asked you
Okay.
questions that I have. Yeah.